Welcome back to my course Industrial Biotechnology. Today I shall continue my lecture on, we concentrate on solid liquid separation process, and we have basically that this process are common to most of the chemical and biochemical industries, and as per and then it has different names. As for example that I work with citric acid industry, and during after the citric acid production we have so many different solid liquid separation process. As for example, initially we use the rotary vacuum filter to separate the mycelia or in the cell mass that is present in the fermentation broth. After that we precipitate this citric acid in the form of calcium citrate, and this calcium citrate we separated in a special another filter, what we call Panavis filter, and after that this calcium citrate we hydrolyze with concentrated H2SO4 and it produce citric acid and calcium sulfate, and which is called gypsum, and this is again passed through the another filter, what you call gypsum filter. After that we pass this citric acid solution through the evaporator to concentrate the citric acid concentration, to increase the citric acid concentration from 22% to 60%, and then we pass it through the crystallizer where solid crystals of citric acid is separated from the liquid, and then again it passes through the centrifuge to separate the solid crystals from the liquid. So we can see that lot of solid liquid separation process are there, and basically in the last class I discussed about rotary vacuum filter, and also I discussed about the plate and frame filter press. Now the whenever we use any kind of filtration process, that again it depends on the size of the particle that we are going to separate. As for example, the filtration process that is used for the bacteria may not be suitable, may not be used for the yeast cells. Actually Baker's fermentation process we use the plate and frame filter press, and for fungal cell mycelial separation we use the rotary vacuum filter. So this way I discussed in the last class. Now today another solid liquid separation process is left, that is centrifugation, that I shall talk about, and then also I shall discuss about other downstream processing that we have. Now let me first discuss about the centrifugal filter. It consists of a stainless steel perforated basket, typically 1 to 2 meter in diameter, lined with filter cloth. Basically we take the material inside the centrifuge and we rotate at a high speed. The solid material they throw to the surface where your filter cloth is there, so it is accumulated on the surface. I shall show you, and then liquid will comes out because this is perforated, so liquid will go out of the system. The basket is rotated at a speed of 25 per second, high speed tending to stretch the basket excessively. The product enters centrally and thrown outwards by centrifugal force and held against the filter cloth. The filtrate is forced up close and remove the liquid outlet. The solid material retained in the cloth. Let me show you this. This is actually the centrifuge where you take the your that material, and when we rotate it very high speed here, then this is the perforated basket, sir, and this is embedded with the filter cloth. So when the solid material strikes to the surface and liquid will comes out through these perforated baskets, and liquid will going out, and then when it is accumulated and take the material out and take the filter cloth out and separate the solid material. So, it can be used in preparation of aspirin, because in the pharmaceutical industry we have aspirin, and for the removal of precipitated protein from insulin. As you know, the insulin is kind of recombinant protein we usually produce through the fermentation process, and it can also handle the concentrated slurry which might block the other filters. Now, the different type of filtration techniques we have depending on the size of the filter, as I mentioned, that we have filtration that is usually size varies from 1 to 100 microns, then microfilter, this again take care the smaller particles. The ultrafiltration again is much smaller particle, reverse osmosis will be little bit more smaller particle, and electrodialysis is more smaller particles. So, this is ionic spetic, this macromolecules, and this is particulates. Now, it is pictorially it can be explained like this. Suppose your mixture is composed of different type of particles, is the membrane filter, then ultrafiltration, nanofilter, then reverse osmosis. You can see how the particle, smaller particle becoming separated from the mixture. Now, let me discuss about another downstream processing that is largely used by the industry. One is called evaporation. Evaporation is nothing but concentration in solution containing non-volatile solid by boiling away the solvent. Just now I talking about citric acid, concentration of the citric acid mixture from 22% to 60%. Now, question comes how you do in the industry. What we have tubular heat exchanger. This is called tubular heat exchanger. Suppose we pass our citric acid solution here, citric acid solution, and here we pass the steam. Let us assume this is the steam. Annular space we have the steam, this is steam. So, when we pass together, what will happen? This citric acid solution will be heated, and then what you have, we throw it in case in the some kind of big chambers, throw it like this, and here when you throw this liquid here, then what will happen, that that vapor will go out like this, and concentrate material liquid, the concentrated liquid will comes concentrated solution of citric acid will comes out from the bottom. So, this is how the evaporation is required. That is why I told you this is concentrating a solution containing non-volatile solid, because we should know, we know that two type of solids are there. One is called volatile, and that is non-volatile. Non-volatile solid means that if you keep the suppose I can give a very simple example. We have non-volatile fatty acid, we have volatile fatty acid. Now, in case of volatile fatty acid like acetic acid, butyric acid, and all this thing, if you keep it in a beaker, after some time you will find everything will be evaporated out. So that is why nothing will remain in the beaker. So we call it volatile fatty acid. Now, non-volatile fatty acid means what? If you keep as for example, if you keep the citric acid in the solution, then citric acid is the non-volatile fatty acid. So what will happen? The water will be evaporated out, and after some times the solid crystals of citric acid will remain in the beaker. So this is how we differentiate the non-volatile solid from the volatile solid. So this is evaporation basically used for concentrating the non-volatile solid by boiling away the solvent, and removal the part of solvent from the solution of the non-volatile solid by the vaporization. Examples are production of orange juice concentrate, production of concentrated sulfuric acid and citric acid industry. Now, evaporation can be used for the different purpose. One is the distillation involve 2 or more volatile components, there we can use that, and then drying process where product is solid. In evaporation, product usually more concentrated in the liquid form, and crystallization, product in slurry crystals precipitated from the solution. So, evaporator used in the process industry, different type of evaporator. The velocity of circulation fluids through the tube should be reasonably high to attain the high heat transfer rate. Circulation can be classified as natural circulation due to the density gradient, and forced circulation applying the external mechanical means like pumps. So, type of evaporators, we have different, we have the tubular evaporator, maybe long tube vertical evaporator where upward flow and downward flow, and there is forced circulation. Another evaporator, we call it agitated flame evaporator. Now, falling film evaporator, rising film evaporator or upward flow evaporator can be used as a falling film evaporator while the direction of the feed will be reversed, because it is flowing up, and that the concentrated liquid will go down. The concentration of highly heat sensitive materials such as orange juice requires a minimum time to expose to the heat surface. This can be done falling film evaporator. Then we have forced circulation evaporator. This is used for high viscous liquid and liquid containing the suspended particles. We have agitated which is a film evaporator, modified falling film evaporator with single jacketed tubes containing a internal agitator. Application is that if the liquid is viscous, its viscosity is very high, then this can be used. High capital cost and high maintenance cost is required in this. Now, crystallization, this is all about the evaporator. Now, I told you that the crystallization is the process of formation of solid crystal precipitating from a solution. Crystals is also a chemical solid liquid separation technique in which the mass transfer of the solute from the liquid solution to a pure solid. Importance of crystallization is the purification of drug, improved bioavailability of drug, choose the most stable form, and a crystalline powder is easily handled, stable, and possesses good flow properties and attractive appearance. So, that this is the crystallization. So, there are different examples we have in the crystallization process. I can give a typical example of this sugar production. And the sugar production is usually can be done in 2 different sources. One is cane from the cane and beet. Beet is largely used in the western country, and cane is used mostly the country like India and Brazil. Now, how we separate the this sugar from the cane juice. Cane juice usually concentrate through the process of evaporation. After that, we reduce the temperature, so the crystals of sugar formation take place, and then with the help of centrifuge we separate the crystals of sugar from the liquid, and liquid we call it cane molasses, and sugar crystals we wash with water and dry it and sell it in the market. So, one is largely used in the production of sugar. Then we have purification of drug, it is largely used. Then improved bioavailability, citric acid production, I just discussed that, and preparation of organic and inorganic active pharmaceutical ingredients. Different in the pharmaceutical industry, it is newsprint as for example is largely used. Now, theory of crystallization is very interesting, how the crystal formation take place. First we shall have to make the super saturation, because if it is under saturation, then crystallization will not take place. If it is super saturation, then and only then crystallization will take place. It can be done in three ways: heating the solution, cooling the solution, and salting out. The first, we heating the solution. What is the purpose of heating? Heating just concentrate the liquid, and then cooling it. And because I can give that a simple example. I was talking about citric acid, fermented citric acid separation process, and citric acid has a transient temperature at 26.6 degrees centigrade. Sorry, 36.6 degrees centigrade is a transient temperature. What does it mean? That at above 36.6 degrees centigrade, citric acid is available in two different forms. One is called citric acid monomer, and another is citric acid anhydrous. So what happens that if the temperature is more than 36.6 degrees centigrade, we get citric acid anhydrous, and in case of if the temperature we keep less than 36.6 degrees centigrade, we get CAM. So usually at low temperature, crystal formation take place. So what we prefer, we prefer that to produce more crystal. That is why we usually initial crystallization we take place with the help of at low temperature, so that we can produce the CAM, and later on CAM we can convert it to citric acid anhydrous by keeping the temperature of the mother liquor, which containing about 30% of citric acid at 40 degrees centigrade. So this is how we can do that. So this is separation of the crystals. We can say it is the salting out. Then how the crystal formation take place. This is very interesting. The atoms of molecules or ion come closer to one another and form aggregate called cluster. So atoms, they coming to each other and form the cluster, and these clusters will combine to form embryo, and in this stage only the latex formation begins, and these embryos combines to form nuclei. These nuclei crystals are formed. So these are the different steps involved in case of crystallization process. First, we have segregated molecules. They slowly they come closer and they form the cluster. From the cluster, they form the embryo. From the embryo, they form the nuclei, and from the nuclei, it produces the crystals. And once the crystal growth has formed, the nuclei formation stops and crystal growth begin. So one crystal, it may be bigger crystal, it may be smaller crystals, depending on the nature of the crystal, that characteristics of the solute that we have in the solution. Now the pictorially that process can be explained like this. This is like this. This is the solution. You can see when we evaporate the solvent, then we cooling the solution. Then particles. We form the super saturated solution. We cool down. Then particle formation take place. That is that molecules. The addition of crystals or breaking this crystal is from the cluster of crystals. You can see the crystals, they will be attaching with each other. After that, the embryo formation is there. You can see this some kind of embryo formation. After that, the nuclei formation is taking place. This nuclei, from that we can get the crystals of different shape and size that we have. We can have the different size of crystals. This is how the crystallization take place. Now different type of crystallization equipment that is in practice. One is drop tube baffle crystallizer, forced circulation evaporative crystallizer, circulating liquid crystallizer, and tank crystallizer. There are different type of crystallizer that is available in the industries. Now drop tube crystallizer used in application requiring the narrow crystal distribution and large average crystal size, because I sell because I work with citric acid industry, and I work with the crystals like tank crystallizer. I shall tell little bit details on that, and the information of this crystallization process already available in the internet. If anybody interested, they can see the details of this process. Forced circulation or evaporated crystallizer is used generally simple crystallization operation where the large crystal size is not required. As for then we have forced circulation evaporative crystallizer. Then we have circulating liquid crystallizer. Circulating liquid crystallizer are used for large scale production of a wide range of crystal product, and like gypsum and inorganic salt and silver salts, silver nitrate. This is largely is used. Now this is the tank crystallizer that we use in the industry, and let me explain this process. It is very simple, that we have the crystallizer that we have simple. It is a tank, and we have agitator, and this agitator is the special type of agitator because we call it anchor, because there are different type of agitator that we have, but here we use the agitator which has very low shear forces, because if the because you can remember I explained that in the fermentation industry we use the impeller. Impeller is like this, which has high shear forces. Now if you use these high shear forces, then what will happen, that that crystal formation will be affected. But if you have high shear force, the crystal formation will be inhibited. But if you have low shear forces, then the crystal formation will not be inhibited. So we use this kind of crystal. We reduce the temperature after concentrating this. I told you that 22% citric acid concentration, we increase the concentration to 60%, and then we put this here 60%, this we put it here in this and we reduce the temperature. Maybe we reduce the temperature about 10 to 15 degrees centigrade, and then this is insulated because the outside is insulated, so the heat loss should be as minimum as possible. So it is the heat loss that is totally insulation outside. So we put it and we move this turret, and what will happen with respect to time, then there will be kind of crystal formation that will take place inside this, and then when the crystal formation maximum crystal formation is taken place, then we take the material out and we pass it through the centrifugation process. And through the centrifugation process we can separate separate the crystals from the liquid, and the liquid we consider as the mother liquid, because after centrifugation whatever liquid that remain, that is called mother liquor, and this mother liquor also contain about 30% of citric acid. So this can be used for the production of citric acid anhydrous. I told you that transition temperature of citric acid is about 36.6 degrees centigrade. Now what we do, we take this in a vessel and we increase the temperature of this vessel to about 40 degrees centigrade, and then we put this is the mother liquor we have, this is the mother liquor we put it here, and which contain about 30% of citric acid. Then we put it cam, here cam we put, and this is the agitator we have. We put a agitator here, and when we put the agitator, then what will happen, the water that present in the citric acid crystals, that will go into the solution. So this is the things that you have. Then then when total that solid that the water molecule present in the CAM, when it go to the soluble form, then we take the material out and centrifuge, we get the citric acid anhydrous, which largely used in the pharmaceutical industries. So in this today's presentation, I try to discuss 3 things. One is centrifugation, how through the centrifugation how we can separate the solid from the liquid. Then I talk about the evaporation techniques, the different type of evaporation technique is used. I work with citric acid industry. I told you there we use the tubular heat exchanger just to heat the liquid, and then we throw it in a vessel where the vapor goes up and concentrated liquid will go down, and this concentrated liquid we cool down and take it in the crystallization process. Crystallization is a separation process. I explain how the crystal formation take place. It take place after the different stages of operation. I think next presentation I shall talk about other downstream processing that is used in the biochemical industries. Thank you.